Hi everyone. So today we are discussing Leetcode problem of the day, which is Leetcode 3202. Find the maximum length of valid subsequence 2. Okay, so I would like you guys to just pause the video for some time and just read the problem statement and read the examples. Okay, once you are done with it, just resume the video. Okay. Okay, I hope you guys have paused the video, looked at the question, or if you are already aware of the question, that's fine. Okay, so I will quickly explain you the problem and then we will discuss how to solve the problem. So you are given an integer array nums and a positive integer k. Okay, and you have to return the length of the longest valid subsequence of nums. Okay, such that it follows this criteria. What is the criteria? Is that every alternate sub0 of sub1, sub1 of sub2, it means every two consecutive elements with and we sum it and make it modulo k is same as the next consecutive element sum and the modulo, right? For example, this 1 4 2 3 1 4. Here if you see, the answer is 1 4 1 4. Why? Now if you see, the sum of every two consecutive is 5 and the modulo with 3 becomes 2, right? Similarly this, so all the modulo, it satisfies this condition. Okay, so let's try to figure out the solution. How can we actually come up with a solution and how to understand this? Okay, so when you first look at it, it looks a little confusing, but let's try to figure the steps out. So the requirement is something like this: sub 0 plus sub 1 modulo k double equal, it should be equals to, again, sub 1 plus sub 2 modulo k. Again, this list goes on, right? So now if I just replace it with x, so this will be replaced with x plus 1, right? Again, this is x plus 1 only and this is x plus 2. So if you see over here, if I say that let's say the array is something like a, b, c, d, e, f, g, something like this. Okay, this is my final subsequence. So what property it is following actually? If you see, what the question asks for is something like this: a plus b modulo k should be equals to b plus c modulo k, right? Should be equals to c plus d modulo k, right? It should be similar like this. So now if I just take one part of it, so if you see a plus b modulo k equals to b plus c modulo k, it can be simplified and simply said that a plus a modulo k should be equals to c modulo k, right? This is the property of modulo, right? Again, if this is the thing, then again, what can be the other thing? That b modulo k should be equals to d modulo k, right? Similarly, if you take this and take the other part, it should be something like this, right? So we can say that either the alternate elements modulo with k should be same, like a, c, e, g, b, d, f, h, or what can be one more case, that a modulo k is same as b modulo k is same as c modulo k is same as, again, d modulo k. Like all the modulos are same. So what are the two cases? There can be two cases. Okay, what are the two cases? First case is that all the remainders, a modulo k, b modulo k, c modulo k, here it is something like all the modulos are same, r1 equals to r2 equals to r3, something like this. Or the second case is that the alternate ones are same, r1 r2 r1 r2 r1 r2, where what are these r1 and r2? These are the chosen subsequences modulo with k, right? This was our chosen subsequence from a very big array. So we are saying that a modulo k should be c modulo k, which is over here. A is equals to c, b is equals to d, but it should alternate, right? So only these two cases should happen. Okay. Now I will tell you one more other property of modulo, which I think you guys know. So any number in the world, modulo k will always lie in the range of 0 to k minus 1. You know this, right? So let's take this example, and I will try to make you understand with the help of this 1 4 2 3 1 4. Okay, let's take this example. So 1 4 2 3 1 and 4, and the value of k is 3. Now if you see the final answer, obviously we know that 1 4 1 4, but how to reach there, right? How to know that 2 should not be the answer, 3 should not be the answer, and everything. So now if you just try to focus, okay, if you just try to understand that with the help of this conclusion, we made very clear that we have to do something with a modulo k, b modulo k. So every element with the modulo of k. And you know it very clearly that whatever the number is here, or length, whatever the number, if we take a modulo of k, the size will always be like 0 to k minus 1, right? So what can be the values of any number with, if we take modulo of k, it can be 0, 1, 2 till k minus 1, right? So for example, for this case, let's see what all could have happened. So what we can do is, if we just define, okay, first I will talk in terms of dynamic programming, and then we will see how it basically implies to our case. Okay, so this is basically a dynamic programming question, and it is very similar to LIS problem. Okay, so linear increasing subsequence and how it basically impacts that. Okay, so for every dynamic programming question, first we will understand that this dynamic programming, and we know that all the indexes can only be in the range of 0 to k minus 1, right? Why is it so? Because at every position we are taking a modulo of k. So it is very safe to assume that if we take an array of dp of k comma k, this will solve our problem. Okay, and what is dp of k comma k? We will understand. So dp of k comma k, we can define it with different number of ways. Okay, so first way which I will define it with, that I will say that dp of I comma j, okay, just focus on the definition, represents dp of I comma j represents number of, okay, represents number, or we can say size of subsequence, number or size of subsequence, where we can say I is second last remainder. We can say I is the second last remainder and j is the last remainder. Just focus on this sentence. I will come back to it again. So I is the second last remainder and j is the last remainder. Why I am saying this? I am saying it because wherever we are here, let's say we are at a random place I, we have to find at the second last remainder and the last remainder. Okay, so I can say that dp, or let's define dp of ij, where dp of ij represents number or size of subsequence where I is the second last remainder and j is the last remainder. Okay, this will become slowly clearer. I will draw this example over here, and then we will try to understand what and how we can achieve this solution. Okay, so this is my array. Now what I am saying is that we will start iterating over this array. Okay, we will start iterating over this array, and with every number, let's say a in nums. Okay, so with every number a that we find, we can define a variable called remainder. So what is the remainder? Right now remainder is a, whatever number is, whether this is the number, this is the number, we can say a modulo k, or we can say here a modulo 3. Right now I will say that wherever we are, if we are here or here or wherever we are, we can say that according to our definition, since I is the second last remainder and j is the last remainder, so we can say dp of ij. So here we will start a for loop from 0 to what we can do, k minus 1, since the remainder can be of any range 0, 1, 2, but at till k minus 1. So I can say that, let's say this is the iteration on k, so we can say that dp of j, I can say that the second last can be any one, but if the last one is remainder, this will be equals to what, dp of where the second last is remainder and the last is j plus 1. Just focus on this statement. This is a very important statement which will define the whole logic and algorithm of our code. So what I am saying, that dp of second last, okay, dp of second last where second last is j and the last is remainder will be equals to dp of second last and second last plus 1. Why? Because we are adding one more remainder. Okay, so what I am saying, that whatever dp we got, whatever value we got till last, when the second last was this and last was this, now since we are adding this remainder, so it will be like this plus 1, so this value will be there, because whatever was till here with adding of this remainder, it got reversed, and we can say that dp of j and remainder, for example r1 comma r2 comma, let's say these are r3 r4 again r1 r2 r5 r2, something like this came. So if you see, and if I just say that k is 2, okay, k is 2, so what can happen here, the remainders can only be 0 or the remainder can be 1, right? So all these values, whatever I am saying, that so the remainder can be 0 or it can be 1, so my dp will look like something like a 2D array with 0 1 0 1. Okay, and with the help of that I can say that if I iterate over this whole number, okay, and let's say r1 is there, r2 is there, I again found r1 and again found r2, so my answer can be 4, because first this everything is initiated with 0, so initially everything was 0. Now I can say that dp of j comma remainder, so since j will start from here, let's say, okay, so if j starts from here and the remainder is, anyways if we are taking the number as 2, it will take as 2, so it will start with 1 2 3 4 and the final, the answer will be 4. Okay, so now I will just pause over here and I will just write the code and we will see the answer, and then I will pause the video, and if you are satisfied with the solution, if you understood the solution, you can just exit the video, or after writing the code I will give a whole dry run with another example. Okay, so I will hope that that will make it understand more clear, since this is a DP problem and a little more complex, so not understanding it is completely fine. Okay, so as we discussed over here, what we can do, we can just define a DP. Okay, and what will be the size of the DP? We can make it of size k cross k. Okay, now what I want to do, if you already know that in Java, if we initialize like this, all the values are initialized with 0. Now what I want to do is I will start an iteration from 0 of this whole array. We'll do nums dot length and then increase the value. Just give me a second. And I'm doing this and then increasing this, and then what I am saying is that I will take the remainder, which is nums of, okay, you know already this, that I can say nums of I, and wherever I want I can just take the remainder like this. And now I can say that since I know that this remainder right now what it is coming, it is the last element, so I can say the dp of the, now here I will start a inside j loop, a for loop from 0 to k, since we know that the value of j cannot be more than the value of k, which is the, if we take a modulo, it can't go exceed more than or equal to k. So now here I can say that dp of, since this is the remainder, so I can say dp of whatever the value of j could be, since I am saying that dp of x comma y, it means x is the second last element and this is the last element, will be equals to dp of, when I take it remainder as the second last element and j as the last element, and make it +1. How are we doing this? So dp of j comma rem says that rem is the last element, j is the second last element. So if j is the second last remainder and rem is the latest remainder, it will be equal to, when the j will be the second last remainder, just forget for this and go to the back, and that +1, this 1 is actually this value remainder. And here what we can do, we can just keep a variable called res, which is 0, and at every moment we can just keep on updating the value of res, which we will return as answer. And we can say that math.max, we can say that this is either res or dp of j comma rem, which we just updated, right? And now after everything happens, we can simply return res and this should work. Okay, let's try to run this. Okay, accepted. Let's try to submit this. Okay, this got accepted. Cool. Now, as I mentioned earlier, this code looks very small, but it is a little trickier to solve. So if you are able to understand this till now only, you can just exit the video, or I am again going to start with the help of this example and I will create a whole 2D array and I will try to explain you guys. Okay, so if you are if you are understood, you can just leave or you can just follow me. So 1 4 2 3 1 4 k equals to 3. I will try to do this. So I will make here a first whole list. We will make 1 4 2 3 1 4. I hope this was the question. 1 4 2 3 1 4, and the value of k equals to 3. So if you have seen k equals to 3, what was the size of the dp that we would have created? 3 cross 3 for sure, right? The value should have 3 cross 3. So I am creating a 3 cross 3 array, and with the help of this, now we will go and look for a dry run. Just be with me and we will completely understand the problem. So we'll start with the outer for loop. We'll start from here, and we saw, and everything, see, initially everything is initialized with 0, right? If it is Java, it already initializes. If it is some other language, we will do it manually, but that's not the problem. The condition is we will initialize everything with 0. Now we are saying that we will start the iteration from the first element, and for the first element, okay, just follow me here and I will try to start writing it over here, that for my iteration 1, here what are we doing? We are finding the rem. What is rem? The remainder is nums of I comma k. So what is 1 modulo k? Can you tell me what is 1 modulo k? Okay, so 1 modulo k is basically so 1 is here 1, k is here 3. So 1 modulo k will become, let's try to see this. Okay, if you're confused how to do this, so if you do this, 3 zeros are 3, it will become 0, 1, 3. So it will be basically 1 modulo 3. If you see it over here, 1 modulo 3 is 1, right? So when you do this, whatever remains here becomes the modulo. So 1 modulo 3 is 1. So here now remainder becomes 1. Now inside this iteration 1, I will start writing this. What I will write? I will write iteration of, there will be 3 iterations. How there will be 3 iterations? How do I know? J equals to 0 to j less than k, and k is 3. So there will be iteration 1.1, there will be iteration 1.2, and there will be iteration 1.3. Okay, we will understand how these all iterations are happening and everything. So now since we have this rem value, now what is happening? We are saying that dp of j comma rem. So here in iteration 1.1, j equals to 0, here j equals to 1, and here j equals to 2, right? Now I am saying that dp of 0 comma remainder, it means 0 comma 1 becomes dp of, what is that? The reverse, dp of rem comma 0. It means that the second last index is 0 and the last index is 1. Here we are saying that second last index is 1, last index is this, plus 1. So if you see initially everything is 0, so obviously this will be 0 plus 1. So if you see dp of 0 comma 1 became 1. What is dp of 0 comma 1? This is 0, this is 1, so this became 1. Just follow me. Now since we did this, and res we will take care of later, because res is basically whatever is maximum in this array, right? So we can take it later as well. Okay, second iteration. So here we are again saying that dp of, what are we saying? J comma rem, it means dp of 1 comma, what is rem? 1 equals to dp of rem, which is 1, and j is also 1 here, plus 1. So dp of 1 comma 1, what is here dp of 1 comma 1? 0, it became 1. So dp of 1 comma 1 is became also 1. Okay, first we will make this whole thing and then we will tell what each thing signifies. Okay, so if you just understand what is this signifies, it means that any dp of 0 comma 1, so right now if everything becomes 1, it means that at least 1 is the answer, which is for sure true. So which we can just do it right now and then we will understand what it means. So now j becomes 2. So we again dp of j comma rem, which was 1, equals to dp of rem comma j. So 1 comma 2 was this, plus 1 we did, so it anyways become 2. So dp of 2 comma 1, here also we have put 1, right? Okay, now since this was iteration 1, now let's make iteration 2 and see how it goes. Okay, so iteration 2. Okay, in iteration 2, if you see what is going to change, there will be, we will first find the rem value. What is the rem value? If you see, the value of rem was nums of I modulo k, nums of I, which is 4 modulo 3, so it again becomes 1. And then here how many itrs will run, how many iterations under this will run? The number of iterations under this will run will be again 3, itr 2, itr 2.2 and itr 2.3. Why only 3? Because if you look at the code, it is k, j less than k, and k is 3 only. So here again we will keep on increasing these values, and if you see, as we keep on improving here, keep on increasing here, we will just increase all the values of this 3 cross 3 array, and we will ultimately find that what is the, and we'll ultimately find the maximum of this. Okay, and how can we prove this? The proof of this is the dynamic programming constraint only what we made. So what was the dynamic programming constraint we made? That dp of I comma j is defined as that the number, okay, or size of subsequence where this is very important, where I is, you can say, second last modulo, okay, I is second last modulo and j is last modulo. And how this can be defined mathematically? We can say that dp of where I is the last modulo and j is, I is the second last modulo and j is the last modulo, this will be equals to, like for every new number, this will be equals to when j is the second last modulo and I is the last modulo, like r1, r2, r1, r2, r1. Now if we are facing, if we just came here, we can say that what was the value of r1 when r1 was the second last element and r2 was the last element. So dp of this plus 1, because this r1 is going to contribute over here. So this plus 1, and this is how we are able to solve the problem. You can take a look at the code, and if you submit the code, like this is a very small code, but this is what is a tough part to understand. Okay, so thanks for that, thanks for watching the whole video. And if you are still here, I would just like to tell you about, so this is me, this is the my LinkedIn profile. You can have a look into it. Right now I'm working at Amazon as an SD2, and what I just wanted to discuss with you is you can book sessions with me. Okay, so if you just want to discover, if you just want to talk to me about anything, you can book a 15 minutes free video meeting where I will just come and I will talk to you. I'll be very happy. If you want to have a quick chat about any promotional thing, about any in preparation or anything that you don't know how to do it, I can be there. I can have a resume review session with you, I can have a mock interview session with you, or I can just sit with you and I will make the interview preps and tips. These prices will keep on going up and high depending on the number of people applying. So yeah, make sure you take a look whenever you want to discuss with me. Okay, so I will be back the next time with the next video. Thank you so much. Bye bye.